right, y'all, so this is 6-2A, and I can tell you this is probably one of the most important fundamental lessons for this entire unit. So make sure you understand everything that I'm talking about today. So there are two ways to measure angles. And the first one is degrees, and that is really what we have done always in your math career here. But now we're going to do radians. And so if you are just watching this video and you weren't in class, we did an exercise to show what a radian really is. So go watch my video on what is a radian based on this exercise. So think about this. So if we look at distance, any type of distance, if you're here in the US, we talk about miles. If you're anywhere else in the world, they talk about kilometers, right? So we have two different distances. If we talk about temperature, here in the US, we talk about degrees Fahrenheit. If you're over in Europe, we talk about degrees Celsius. So we have different types of measurements, but basically there's a conversion that'll take you from Fahrenheit to Celsius or miles to kilometers, and that's what we're going to do right now. Now I'm going to show you something on your calculator right now, and then we are not going to use our calculator, but I just want to show you this because it's super important. So under mode right here, what you're going to see is that you have the option down here to go between radians and degrees in your calculator. And so when we get to application problems where you're able to use your calculator, just know that you have these buttons between degrees and radians. I think we actually have a lesson that'll even show you how to do that. Okay, so what is our conversion formula? Well, our conversion formula has to do with the fact that, remember in trig, what we're dealing with is our angle here is a rotation. And if we're to rotate all the way around the circle, we would go 360 degrees. Well, if we go all the way around the circle, 360 degrees, that is the same as 2 pi. So if I create this ratio, just like I could up here, so I could say that there's 5,280 miles, and in that I would have, 5,280 feet, in 1 mile. So I create this ratio. It's the same thing here. I have 360 degrees in 2 pi radians. Well, this simplifies to 180 degrees in 1 pi radian. If I just divide this by 2, so this is what we care about. So our conversion formula is going to be 180 degrees over pi. Now, because this is a ratio, I can convert this, and I can say pi over 180 degrees. So just like in chemistry or just like in physics, depending on what you're looking for, you'll determine where your degrees go and where your radians go, and you can flip-flop that. So what happens when we're changing from radians to degrees? We want degrees. So what we have is 180 degrees over pi. So we can write it like this, and when we do this, our pi cancels out. So this is the same as saying we can substitute pi and 180 degrees. Okay, so let's practice this. If I have this, I'm going to do this two different ways. So if I have this pi over 3, then to convert this, pi over 3, I can convert by 180 degrees over pi. And when I do this, my pi's cancel out. And when my pi's cancel out, I end up with 180 over 3. So a shortcut when you do this is to take this part of it and say, okay, if pi equals 180, I'm just going to rewrite this as 180 over 3. Now, we have to do the math to simplify this down. So we're going to do all of this without a calculator. So if we have 180 divided by 3, this is the same as 18 divided by 3. So we know that this goes in there 6 times. So this would be 60 degrees. So pi over 3 is the same as 60 degrees. Okay, let's go down here and do this one because this one's a little bit easier. So if I have 5 pi over 6, this is the same as saying 5 times 180 over 6. Well, we just said that when we have 180 divided by 3, I get 60. So 180 divided by 6 is going to give me 30. So 30 times 5 is 150 degrees. All right, same thing here. So I have 3 times 180 divided by 2. So I'm going to reduce this. 2 and 180 becomes 90. So all of this simplifies to 270 degrees. Okay, now we're going to do this last one, and I'm going to do this last one a little bit differently. So again, I have 180 over 4. Now, all of these other ones that I've done, my denominator divides evenly into 180, which makes it super easy. But this one, 4 doesn't go into 180. In my mind, I can't do it quickly. So what I'm going to do is I'm just going to say I can reduce both of these by 2. This is the same as saying 180 times 2 times 2, right? So I divide this 4 into 2 times 2. So 2 goes into 180 90 times. So 90 divided by 2. And then I can do it again. What is half of 90? Half of 90 is 45 degrees. Now, this is important. All of this changing back and forth, so changing radians to degrees and degrees to radians, this will be done without a calculator. So you just have to memorize these. Some of them you're going to see, actually all of these you're going to see again, and it's going to be really easy to see. Let me give you a couple of little tricks on this though. We have this denominator of 3, we have a denominator of 6, we have a denominator of 2. Every one of these goes evenly into pi, and when it does, into 180, all of my values are going to end in a 0. So this is going to end in a 0, this is going to end in a 0, and this is going to end in a 0. You're going to see that the denominators of 3, 6, and 2 are super, super common. So these are our standard denominators, and then we have this denominator of 4. A denominator of 4 is always going to end in a 5. So the denominators that you need to know are 2, 3, 4, and 6. These are the denominators that you're going to have to memorize. So all of them will always go into 180. When you have a denominator of 4, you might need to split it up. All right? Okay, so we're going to go the opposite direction now. So now what we're going to do is we're going to go from degrees to radians. Well, remember we said that this is just a ratio. So if I'm going from degrees to radians, now I'm going to multiply 1 pi over 180 degrees. So again, think of this degree as a unit, and what we don't really say is we have pi radians over 180 degrees. So I have units, just like my little example up here with feet and miles. These are my units, radians and degrees. So if I start with 30 degrees and I need my units to cancel, this is going to be pi over 180 degrees. So my little unit of a degree is going to cancel out. Well, what I'm doing here is I'm just going backwards. So I know that 30 goes into 180, and when I go the opposite direction, this is going to be pi over 6. So 180 divided by 30 is going to give me 6. So I'm going to do the same thing here. So I have 210, and then this is going to be pi divided by 180. Okay, so if I look at this, 180 and 210, I know that 30 goes into both of these numbers. So this is divisible by 3, 21 is divisible by 3, and 18 is divisible by 3. So if I take 30, I know that 30 is going to go into this 7 times, and 30 is going to go into this guy 6 times. So this whole thing simplifies to 7 pi over 6. Okay, so 120 pi over 180. What do I know here? Well, I know that 30 goes into both of these. I also know 60 goes into both of these. So 60 would be my bigger factor. So 60 goes in here twice, and 60 goes into this one 3 times. So this would give me 2 pi over 3. Okay, now this is kind of fun. So up here I talked about this initial ratio, which is 360 degrees, is all the way around the circle. So all the way around the circle is 360 degrees. It's the same as 2 pi, and this is just our proof. So 360 degrees, and if I'm using the ratio pi over 180, then what I know here is if I take 18 and I double it, I get 360. So this goes in here 2 times, which gives me 2 pi. Okay, that was it. You've got a whole bunch of practice problems.